Welcome back. In this class, I want us to look at operators. And so I'll go to my package and right click, then select new, then Java class, and create another class called operators. Select class. And let's have a class just for operators. So here we want to talk about all the possible operators that are used in Java. The first thing to create is the main method, because every class or every project must have a main from where execution starts. So we start with mathematical operators, and for the mathematical operators, we have the following operators that we need to be aware of. That is plus, minus, then multiplication, then division. And we'll also look at another one called modulus. So these are the mathematical operators. Right away, I want us to start with the first two. I want to conform to Java conventions, so call this 12. I want us to move fast on what you probably are already familiar with. Second number, this could be 15, and I'll just print the output here, system.out.println, and now I want to perform the first operator. I want to use the first operator, which is addition, so I'll call this sum is, and then just use plus to join. Then I will type first number plus second number. Right, until you copy this, do the same for the subtraction. It's complaining. Let's see why this is complaining. Operator minus cannot be applied. Okay, it's trying to use a shortcut. Let's do this then. I think this might be better. In sum is equals to, I'll pick this, cut it, put it here. This would also be a bit more clear to many of us. Sum, then I'll copy this here, write difference here. All right, just so that we avoid the negative number. Just so that we avoid the negative number, I change this to 22. Okay, then the next operation is multiplication. So I can call this difference. Okay, the next one is multiplication. So I put this one here and change this to product. Right, my computer is hanging. Product, and then declare another variable here and store the product. So this is call it prod. Okay, so let me change these operators here. So this is product and this is minus. Okay, let's finish all this before we run, so that we only need to run it once. Say, well, so which one have we not used? Division. And I will show you something very interesting with the division. Okay, so just right here, division is, the English might not be very accurate. Division, right, div here. There you go. Okay. Okay, so I'll need to declare that variable here. We can first look at that. You can first look at that. This is division. We have used 1, 2, 3, 4. Let's run that first and see what we have. I'll click on this, or you can run it from, you can change the class here and then change that, run that, or you can just run it from this part, run operators. So it's running. Let's give it time. Did I click on this? Yes, it's running. So we want to perform, to compute the sum, the difference, the product, and the division. Then we'll go to the last one before we go to a different class of operators. Okay, first time usually takes time, but it's almost done. Right there, the output is about to pop up. Remember to conform to the conventions of Java variables. Really makes your program very readable. Very well. There we go. The output is coming up. Okay, it's taking some time. Right there. So sum is 37, difference is 7, product is 330, division is 1. Is that so? If you divide first number 22 divided by 15, the answer is actually not 1 but 1.46. So why did it say the answer is 1? This is the part you need to be very careful. Anytime you divide integer by integer, you will always get an integer. Anytime you divide integer to another integer, you will always get an integer. Even if you change this data type here to double, the number that you get will still be an integer. And because you're trying to force an integer to be double, the computer will just put 0.0. So this will be 1.0. Let's try this after changing this into double. Let's just run this, see whether we get 1.0. All right, it's running. Let me add in space here, looks better. There's no difference, but as we wait for this to run, we can make that change. Okay, so there you go. Okay, checking. You see, the answer is 1.0. Still, it's not giving the accurate answer. Why? Because integer divided by integer is integer. So what is the solution? What is the solution? We need to do something called typecasting. We need to convert one of the values here, either first number or the second number here, to be a number with decimal point. So look at how I'm going to perform typecasting here. I just type double. What does that mean? I'm trying to force the first number here to be double, because double divided by integer is always double. So now look at the difference. Right, it's running. I'll be preparing the place for the next operator as we wait for this. So the next operator we'll be looking at is modulus. Modulus. Let's see the output here. Right. There you go. My computer is a bit slow. Okay, so there you go, 1.46666. This is now accurate. Please remember that. It is important that you remember that. Let's use the last mathematical operator that we've not used, and that is modulus division. So don't forget the name. Modulus division. What does it do? it divides two values. So this is what will happen. And let me call the remaining number or remaining value. So this is what this will do. It will take a value, divide it to another value, and store what remains. So I'll take first number, modulus, divide it to second number, and whatever remains will be stored under remaining value here. So let me print this. Can anyone get? So when we run that, you get 7 here. You can see 7 here is the remaining value. So let me try use this a bit more creatively. We want to ask the user to enter any number. Let's try this. So some of the places you can use this. Any integer number, just a number without a decimal point. Then we need to receive this number at runtime, so I'd use a class called scanner. We introduced this last time. Input is equals to new. Understand what this new means with time. Use scanner, then system dot in. Now we can receive this number, so we might need we actually will need a place to store that number. So I'll just call it user number. So right here I write user number, then receive it from the input dot next int, because it's an integer. So by the time we get here, the user has supplied an input, and now we need to check whether what the user enters is divisible by 11. So I can just say if whatever the user enters, modulus divided by 11. If whatever the user enters, if we perform modulus division by 11 and what remains is 0, then we know that the number that the user entered is a number that is divisible by 11. So look at what I type here. System dot out dot println. So I will type, I want to start by typing that number that the user entered, so I put it here, and the number is stored under user number. So user number plus to join is, I'll leave some space here so that it will looks good, is divisible by 11. So what if whatever remains here after the division is not equivalent to 0? It means that number in the first place, the number that the user entered, is not divisible by 11. So I'll just copy this and change the statement to negate that is not divisible by 11. So let's run this program, see what happens. This will be a slightly lengthy video because we have to cover a number of operators. Right. Very well. So enter any integer number. 56. Enter. 56 is not divisible by 11. I hope you can relate to what is happening. 56 will be divided by 11, and whatever remains will be stored here or will be replaced with this. And if it's not equivalent to 0, then it's not. Let me run the same program and now enter a number that is divisible by 11, like 33. 33 is divisible by 11. The next operator that we want to be aware of is the assignment operator. Please, this is not equal to. we call it assignment operator. And mostly we use it to assign values to variables, as you can see here. As you can see here, this is assignment operator. We have assigned the value 22 to the variable first number. So we don't need to write a program to demonstrate that, but just know that this is an operator that we refer to as assignment operator. The next set of operators I want us to look at is relational operators. Relational operators are many. They include greater than, less than, then we have greater or equal to, then we have what is that, less or equal to, then we have equality operator, then we have not equal to, not equal to. These are known as relational operators. They guide how values relate relational. Is one value greater than the other? For example, in our program here, we have first number at 22, second number at 15. We can write a program, a very simple one here, to check whether how these values relate. So I'll just start with if first number is greater than second number. So this particular part will reduce to true if first number is actually greater than this. So I'll use braces, and I will use else part here. I will explain why we need this. So if this is true, then this message will be printed, else this message will be printed. So system dot out dot println, and I will write first number is, I need to join this string, is greater than second number, and we can copy this statement and put it here. What if this is not true? Then we need to interchange this second number is greater than first number. So you will need to familiarize yourself with all the relational operators, but we will just have an overview of this operator so that you have an idea of how they work very well. We still have the previous logic here. So I'll just enter some number like 22. That was not important, but without that we cannot move here. So 22 is greater than 15. You will see if you interchange these numbers, instead of 22, put this as 25. Let's see what happens now. Very well, we're there. So enter any number, just the previous logic. It now says 25 is greater than 22. So this operator is very important. The opposite of this is this. Now let's try something interesting here. What if we set the same values, all the variables to the same value here, 25 each. Let's run, see what happens. Will it say 25 is greater than 25? Let's see. So the previous logic, 22. Oh, it actually says 25 is greater than 25. So look at that. Look at that. All right. I want us to slightly change this so that we can compare whether these values are equal. Look at that. This is the equality operator. So I change this to just equal. And I change this to not equal. Not equal. Just run it, see what happens. remember the two values are actually equal. Okay. So it says that the two values are equal. All right. We take note of greater or equal to. The moment you add this, then it becomes inclusive. Let's see what happens. This means, is 25 either is first number greater than second number? It could be yes. Or is it equal? So take note of what will happen now. It will return, or rather, let's wait, see what it returns, see whether we can interpret it. Write any number here, 33. It says they are equal because we are checking both. We are checking whether it is greater than or whether it is equal to. One of them works. Now, this not equal to, look at what happens. Is first number not equal to second number? What do you think would be output? Let's see what happens. Okay, let's apply this for the sake of that. So it says not equal. In other words, this is what is happening here. It will check, is first number not same as second number? If this condition is true, that second number is actually not as first number, then this will be printed. But now that they are equal, this statement becomes false and it has to print this part of the statement. Those are the mathematical operators that are very common in programs. So you need to be very keen with this. For example, in Kenya, the age where, let's assume we start voting at the age of 18, for example, then would say if somebody is 18 years and above, that is equal and greater than. If we use equal, it means only people who are 18 years can vote, but now we are looking at 18 years and above. So we'll take note of that. The next set of operators, we will refer to them as increment, and or decrement. Increment or decrement operators. Look at this. I have a number like int num and set it to 89. Then write something like this, num plus plus, and then print the value of num. Let's see what happens. Here, what am I missing? Okay, int num, something is not correct, sorry. Call it number, I don't think that's the problem. Oh yeah, I get it. Sorry. So we need to store this somewhere or just print it. So let me just call this int new number. So look at that, sorry for the confusion. So I do something on this number, then store the resulting value here. Then I now print this number. So let me retype this so that we know where the problem is. I'm actually missing something here. Okay, let me see whether my braces are okay. Okay, let me start system dot. Okay, just a minute. Okay, so let's continue. I had a mismatch of the braces. So we want to print this particular value here, system dot out dot print line, But I think what I had before would still suffice. Let me try something. This should still work, yes. And now we want to print number, the new number. We're trying to understand increment and decrement operators. So let's see what happens with this. I will run this. I'm still using the previous program, so you will see some output that we might not need now. But let's put everything together in the same program. So, okay. So look at what happened. Even though this is 89, when we put it this way, then and print it out, then we get 90, because this one adds 1 to this. So an increment operator adds the value 1 to the operator. In other words, this is the same as saying number is the same as number plus 1. Those two statements, this statement and this statement, are equal. So look at what I want to do here. Number minus minus. This minus followed by a minus, we call it a decrement operator. So now I want to see if this is 89, will it print 90? Then after this, print 89. So this one minuses 1, and this is the same as number is equals to number minus 1. When we start talking about loops, we'll be using a lot of these statements. So let's run this, see what output we get. It's almost there. Very well. So there you go. It is 89. You add 1, you get 90. Then you minus 1, you get 89. Increment and decrement operators. The last set of operators I want us to look at is logical operators. Sometimes some books will refer to these as conditional operators. So what does this mean? If we want to join, especially relational operators, you have a number of conditions to check. For example, when you log into a system, we do not only check your password, we also need to check your username. Both your username and your password need to be correct. Not one of them, both of them need to be correct for you to be allowed in. So look at this. So I will just declare, just look at this. If pass is 555, just for example, and int username, of course we know most of the times this will be in string format, but for now we can use numeric 33. So this is the predefined password, this is the predefined username. So we want to use a condition here. If password is equals to that one, and we don't just want to check the password, we also want to check the username, then we will need to use this particular operator. It is called AND. So here we have this one AND, and we have this one OR. Lastly, we have NOT. These are the logic operators. So let me okay, I don't want to receive these values from the user so that we save on time. So I assume this is the password that the user has supplied, and the password is 55 here, the one that is set in the system. And then and username is equals to 77. So look at what happened here. Write the else part. So here I'll just print dot println allow login. Supposing those values are correct, we will allow login. Here, do not allow login. So these are the user credentials that the user has supplied, but the correct password is this, and the correct username is this. So let's just run this, see what happens. So we are the previous logic. It says do not allow login. Why? Because the password is correct, but the username is not correct. If we only need one to be correct for us to allow login, then we need to change this from or to and, from and to or. So this one means any of this needs to be correct, just any of them. So let's run that, see what happens. So you see, when we use logic operators, we can combine so many relational expressions together. All right, this is a lengthy video, but this is the last operator that we are looking at. Very well, here we run the previous logic. It says allow login right here. Why? Because only one of these needs to be correct, and this part is correct. In fact, Java does something that we call short circuiting. What this means is this: if it has already evaluated this part to be true and you're using OR, it doesn't even need to check this part. Right, the next one is not. Sorry. The next one is not. That will be combined with this. And you can still use any of the others here. And you already can tell what will happen here, because this is and this is not. Actually, let's just run this. This might surprise you. All right. I hope you can already begin to anticipate some kind of output. Allow login. Why? Although this is and that expects both to be true, here we have said not true, not. And therefore, the whole thing here reduced to true, and this reduced to true, and that's why it said allow login. These are the common operators in Java. So we have mathematical operators, assignment operator, increment and decrement operator, then we have the logical, and of course we have the relational operator. Here we have looked at relational operators.